Team 1 of Section T1C is proud to present the Ariane 5 rocket as our Solidworks project. The Ariane 5 rocket is a European heavy-lift launch vehicle developed by the European Space Agency and operated by Arianespace. The specific version used to launch the James Webb Space Telescope is the Ariane 5 ECA, a highly reliable configuration optimized for deep space missions. The Ariane 5 solid rocket boosters play a critical role during liftoff. Each booster consists of a strong booster casing, which also functions as the fuel tank, housing the solid propellant. Once the boosters have exhausted their fuel, they separate from the rocket. A parachute system is then deployed, which slows their descent and allows them to safely fall back to Earth for recovery. Between the boosters and the core stage is the thermal curtain, which acts as a protective barrier. Running along the exterior of the booster is the systems tunnel, which houses essential wiring and control lines. The Vulcan engine is a liquid rocket engine used on the Ariane 5 launch vehicle, designed to provide high thrust using cryogenic fuels. At its core is the combustion chamber, where liquid hydrogen and liquid oxygen mix and burn to produce extremely high temperature gases. Surrounding the chamber is a cooling system, where liquid hydrogen circulates to absorb heat and prevent structural failure. This component is the upper composite, which consists of the upper adapter, Sodia 5, LVA, lower adapter, vehicle equipment bay, and cryogenic upper and interstage. The external structure is reinforced with vertical stringers and horizontal frames, designed to carry the axial loads of the upper composite and payload during the ascent phase. Internally, we find a dual tank configuration. The upper LH2 tank and lower LOX tank both feature isogrid stiffening for optimal strength-to-weight ratios. The assembly is capped by the VEB and Sodia 5 system. The James Webb Space Telescope is a next-generation space observatory designed to study the universe using infrared light. The solar array extends outward from the spacecraft bus and provides electrical power by converting sunlight into energy. At the front of the telescope is the primary mirror, which is composed of 18 hexagonal gold-coated segments. Positioned in front of the primary mirror is the secondary mirror, which is mounted on a support structure. Its function is to receive the light reflected from the primary mirror and redirect it towards the telescope's instruments. Behind the mirror system is the Integrated Science Instrument Module. This module houses the telescope's main scientific instruments, including cameras and spectrometers. The structure that supports the mirror is known as the backplane. It provides a rigid and stable framework that holds the mirror segments in precise alignment. Beneath the telescope is the sun shield, a large 5-layer structure made of heat-resistant material. Its purpose is to block radiation and heat from the sun, earth, and moon. The main cryogenic stage of the Ariane 5, also known as the APSC, is designed to store and manage extremely cold liquid hydrogen and liquid oxygen. These propellants are kept in two large separate tanks, a hydrogen tank on top and a denser oxygen tank below. Externally, the stage has a smooth cylindrical shape with a protective outer layer that minimizes aerodynamic drag during ascent. Its structure is carefully engineered to handle both the intense vibrations at liftoff and the extreme temperature differences between the cryogenic fuels and the surrounding atmosphere. The tanks are built from lightweight aluminium alloys to reduce mass while maintaining strength under pressure. The fairing is a cone-shaped shell at the top of the rocket to protect the JWST from aerodynamic forces and heat as it enters the atmosphere. The external is smooth to reduce drag, whilst the internal is lined with foam panels for thermal insulation, preventing ice formation that can damage the rocket.